This lecture explains about CLR and its components. CLR stands for Common Language Runtime, which is the most important component in .NET. CLR is the execution engine of .NET programs. That means any .NET program that is written in any .NET language must be executed based on CLR only. That means .NET program will not execute based on operating system directly. So based on the operating system, CLR will be installed, which is a predefined software developed by Microsoft. And based on the CLR, our actual .NET program will execute. CLR is common for all types of .NET applications, includes desktop, web applications. It is the code execution environment which is common for all .NET languages, includes C#, VB.NET, VC++.NET, etc. CLR is a part of .NET Framework, and .NET Framework is pre-installed in most of the versions of Windows. For example, in Windows 7 and Windows 10, .NET Framework is already available as a built-in feature. CLR provides several runtime services which are essential to run our .NET application. It not only converts the IL language into native machine code, but also provides several runtime services related to memory management, garbage collection, exception management, thread management, etc. In order to accomplish all these responsibilities, CLR has several subcomponents. So those are class loader, memory manager, garbage collector, JIT compiler, exception manager, thread manager, and security manager. For understanding how all these components execute, we are taking an example of C# program. Yes, as of now I have not introduced any concept of C#, but in further lectures we will understand all these concepts of classes, objects, keywords, operators, etc. My target is, in this lecture I want to make you clear how the CLR executes. So don't much confuse about all the concepts such as class, fields, methods, etc. Only focus on the concept of CLR, but don't worry about the other C# language concepts. So you have a class called employee, which contains several fields, which is responsible to store the information, and you have methods to manipulate the data. And then you are creating objects. You are creating two objects based on the employee class. So how the CLR manages all this code at runtime? When the execution is started, the class loader is responsible to load the classes whenever they need. Remember, whenever there is a requirement of accessing the particular class, then only the class gets loaded. If the class need not be executed or need not be called by the caller, the class will not be loaded. For example, in this program, the execution starts with the main method, but while creating the local variable that is x equal to 10, the class called employee is not loaded so far, because we have not yet accessed the class name even for the first time. But in the next statement, we are creating an object of employee class. So in this case, the employee class needs to be loaded. Then the class loader component of CLR will load the employee class and be aware of its fields and methods, including its data types or return types. So overall, class loader is a component of CLR which is responsible to load the class into memory before its execution. But class loader cannot execute the actual code. Class loader cannot allocate any memory. Class loader cannot delete any memory. So there is a necessity of other components to be involved in the process of execution. The second component of CLR is memory manager, which is responsible to allocate the memory for all the objects and local variables. Local variables are stored in the stack, objects are stored in the heap. but don't much confuse about what is local variable and what is object. I will explain about all these concepts in detail in the further sections. So what I want to say exactly is that the memory manager is responsible to allocate the essential memory for all the objects and local variables, even for parameters. So the memory manager is only responsible to allocate the memory. But who will delete the memory after the usage? For example, we have created one or more local variables here and one or more objects here. So the memory manager component has allocated the memory, and whenever the control reaches to end of the method, all these local variables should be deleted, and at the end of application execution, all the objects should be deleted. So which component will be responsible to delete the memory? That is garbage collector. So the garbage collector is responsible to free the memory by deleting the objects that are created by memory manager. It will identify the unreferenced objects that are not having any references in the program and delete those objects in memory. In the further sections, we will deep dive into garbage collection process and understand how the garbage collection identifies the objects and delete them, and also understand the generations in garbage collection. The fourth component of CLR is JIT compiler, which stands for just-in-time compiler, which is responsible to convert the IL code into native machine language. Yes, it is required because IL code cannot be executed by the hardware directly. So the hardware components such as processor cannot understand the IL code directly, whereas IL code is common for all the operating systems and all the hardware devices. And every operating system has its own native machine code. So that is the reason there is a necessity of converting the IL code into native machine language. Then only the native machine language will be executed by the hardware with the support of operating system. So the JIT compiler overall will convert the IL code into native machine language in order to execute it. But JIT compiler will not compile the complete source code of IL into native machine language at a time. It will convert the source code which is loaded by the class loader. For example, we have created an object of employee class, then only the class loader component loads the employee class into memory. Then only JIT compiler will convert that employee class into native machine language. And then the same class will be executed. The next component is exception manager, which will catch all exceptions that are raised during the execution of the application. You may have different exceptions, for example, system exception, application exception, Stack Overflow exception, invalid operation exception, SQL exception, format exception, etc. So the exception manager component is responsible to catch all the exceptions and execute the appropriate catch block which are written by the developer. I am using some specific programming related words such as catch block, classes, objects, etc. So if you are not aware of object-oriented programming earlier, don't worry about all these things. In the further sections, we will understand all these concepts. The next component of CLR is thread manager, which is responsible to create, run, and stop the threads. The thread is an object in .NET which is responsible to execute the code. By default, every application contains a thread called main thread, and you may create multiple threads based on main thread. So thus you will make the application multi-threaded. So whenever you want to execute multiple individual processes simultaneously, then you will use the threads. And all those threads will be executed by thread manager. And finally, we have security manager, which verifies every statement before execution, whether it makes any harmful changes to the system or not. So if the program is trying to access certain hardware resources, but the current user has no permission to do so, then the security manager will automatically block that operation and raise the appropriate exception to prevent the program from execution. So these are the important components of CLR. In the next lecture, we will understand .NET Framework architecture.